Hello, this is Algebra 2, Lesson 74, and this lesson covers uniform motion with both directions given. Alright, so this first problem is about Friar Tuck. He rode 24 miles to the fair in Nottingham at a leisurely pace. He stayed too long at the fair and had to double his speed on the way back in order to get home in time. If his total traveling time was 9 hours, how fast did he travel in each direction? What were the times? So we're going to have our distance there and our distance back. So our basic equation is distance equals rate times time. So we're going to have distance going equals rate going times time going. And then we're going to have our distance back time equals our rate back times our time back. And our variables are distance G, rate G, time G, and our distance back, rate back, and our time back. Okay, he rode 24 miles, so the whole thing was 24 miles, and that would be the same as the distance back. Okay, so those are equal. Our rate going, alright, so he had to double his speed, so our rate going is our 2 times our rate going would equal our rate back. So we went twice as fast on the way back. Okay, so if he was going 4 miles an hour there, on the way back he would have gone 8 miles an hour. I got that wrong. Let's see. It's 2 times the rate back. Let's see. The rate back equals 2 times the rate going. There we go. Twice as fast on the way back. Alright. And his total time was 9 hours, so our time going plus our time back equals 9. And we could rearrange that to say something else. Our time... Now pen's not wanting to write good today. Our time back equals 9 minus our time going. Alright, now we have TB right here and RB right there, so we're going to use this equation. Okay, so DB is 24, so our distance back is 24, and that equals our rate back, which we're going to rate back times our time back. Okay, so we've got 24 equals our rate back, which would be 2RG, times our time back, which would be 9 minus TG. Alright, now we're going to rainbow that. So 24 equals 9 minus 18, RG, minus 2 RG TG. Well, RT, that means our rate going times our time going, which is the same thing as our distance going, so that would be 24. So we're going to say 24 equals 18 times our rate going minus 22 times 24. RGTG is going to be equal to 24 because that's our distance. That's our rate times time going equals our distance going, which is 24. That's the key to this equation. These types of equations is finding this double variable and substituting in. Alright, so now we've got 2 times 24, so that would be 24 equals 18 times our rate minus 48. So then we add 48. And that will be 8 and 4 is 12, 4, 5, 6, 72. And then we divide by 18. And that's going to be 4. 4 times 2 is 8, right? 72 divided by 18. 8 times 4 is 32. 4 times 1 is 4, 5, 6, 7. Yep. So our rate going is 4. And that means that our rate back would be twice as fast. So that would be 8. And then we can figure these out pretty easily. So distance equals rate times time. So 24 is our distance equals our rate, which is 4, times our time, divide by 4. Our time equals 6 times 4 is 24. And then this one we can do the same thing. Or we can just say the total was 9 hours. 6 hours plus 3 hours would make 9 hours. Once you figure out one variable, all the rest of them are really easy to fill in. And so there's our answers. The ones that we would need to answer the actual question was how fast do you travel? So our rate going and our rate back, 4 and 8. And what were the times? 6 and 3. All right, next problem. Atlanta. I hate when they use these terrible names that I don't know what they are. Okay, so she ran 4 times as fast. 4 times as fast as her challenger. She ran 80 miles in 2 hours less than it took her challenger to run 28 miles. Okay, so we've got our distance equals rate times time. And we're going to have our distance of A, our rate of A, and our time of A. And then our DC, rate for C, and time for C. Okay. She ran 4 times as fast as our challenger, so our rate of A equals 4 times the rate of C, the challenger. She ran 80 miles, so her distance is 80. In 2 hours less, her time's 2 hours less, so time of A equals time of C. If hers is 2 hours less, then we got to subtract 2 over there to make those even. Okay, and her challenger ran 28 miles. All right, so that also means that the time of A times the rate of A equals 80, because the distance is rate times time, and then time C, rate C equals 28. Okay, so we have RA and TA, so we're going to use distance of A equals rate of A times time of A. Okay, and the distance of A is 80, so we'll fill that in with 80. The rate of A is 4 times the rate of C times the time, TA, which would be TC minus 2. Okay, now we're just going to rainbow this out. 4 RCTC. 4 times 2 would be 8, negative 8 RC. Now we know that RCTC right here is 28, so we're going to fill that in. 4 times 28 minus 8 RC. 4 times 28. 8 times 4 is 32. 4 times 2 is 8, 9, 10, 11, 12. 9, 10, 11, 112. 80 equals 112 minus 8 RC. Now we're going to subtract that from both sides. 8, 9, 10, 11, 32. And that's negative 32 equals negative 8 RC. And now we divide by negative 8. These negatives cancel each other. 8 times 4 is 32. 4. Okay, so the rate of the challenger was 4. If her rate is 4 times faster than her challenger's, that means her rate is going to be 16. And then we can use this distance, which is 28, equals rate, which is 4 times time, divide by 4. 7 times 4 is 28, so the time of the challenger is 7. We can do the same thing over here. Get rid of that. We can say distance, which is 80, equals rate, which is 16, times time, divide by 16. Let's say 5, 6 times 5 is 30, 5 times 1 is 5, 6, 7, 8, 80, yep. So that means t equals 5, and that's that one. Okay, and the ones that we would need would be how fast each of them run. Rate of Atalanta was 16, the rate of her Challenger was 4, and then how long did they run? She ran for 5 hours, the Challenger ran for 7. Alright. Pause the video and work that practice problem, and then I'll come back and work it for you. Alright, hopefully you paused the video to work the practice problem, and now we're going to work that out. Use this guy. Bernard raced twice as fast as the local, we're just going to call that D. For this reason, he raced 120 miles in 3 hours less than it took D to race 105 miles. So we're going to have distance equals rate times time. We're going to have the distance of B times the time of B equals distance of B equals the rate times the time. We'll do rate down here. And then we're going to have distance of D, time D, rate D. Okay, so what can we figure out here? Bernard was twice as fast. So the rate of B equals 2 times the rate of D. Okay. For this reason, he raced 120 miles, so the distance of B is 120, in 3 hours less. So he took 3 hours less. We got the time of B and the time of D. He's 3 hours less, so we got to subtract 3 on that side to make them equal. All right. And D ran 105. Okay, so now we can use our distance equals rate times time. We can, okay, this gives us RB and TB. So we're going to use the B. So we're going to say DB equals RB TB. DB is 120. RB is 2RD. Times our time, which would be TD minus 3. And we're going to rainbow that, so three times 2 would be 6. Okay, now we need to replace that variable. So that means that would be the distance D, which is 105. So 120 equals 2 times 105 minus 6. Okay. 120 equals, that would be 210. Now we'll subtract that from both sides. So if we have 210 minus 120, let's see, that'll be 9, 10, 11, yep, 90. 90 equals negative 6 RD. Okay, and then we divide by negative 6. There's a negative there, those cancel, that cancels. And we get 15. Okay, so 15 would be the rate of D. Okay. All right, so now that we know that, distance equals rate times time, we can say 105 equals our rate, which is 15, times our time, divide by 15. Seven. Yep. Okay. Right, get rid of all these scribbles here. Clean this up a little bit. All right, now we need the time. His time was 2 hours less. 3 hours less. So 3 hours less is going to be let's see, that would be 4 hours. Okay, and then we could say this is double the speed, right? So twice as fast, so that would be 30 miles per hour. And there's the answer to the practice problem. Hopefully you guys got that. And that is it for lesson 74. Thanks for watching.